Hello guys, welcome back to part 2 of Reactivity series. So let's start our lesson with some observations for metals that you should know for IGCSE Chemistry with dilute hydrochloric acid. Okay, so for magnesium, right, so the equation would look like this. When magnesium reacts with hydrochloric acid, it will produce magnesium chloride and hydrogen gas. So let me go to another one at the same time, okay? So if it was zinc reacting with hydrochloric acid, it will produce zinc chloride plus hydrogen. But you already know how they will produce, but you need to be able to write down what is your observations. Since both of these reactions would produce hydrogen gas, as you can hear, you can say that there will be fizzing or there will be bubbling, alright? Or you'll be able to see bubbles. And the chlorides of magnesium and zinc, both of them are colorless. And since you have already learned about tests for hydrogen, you can also say that you can test the existence of hydrogen with a squeaky pop test, okay? However, the difference between magnesium and zinc would be that since magnesium is higher in the reactivity series, it's going to react vigorously, while zinc will be giving a steady reaction. So for iron is going, if the charge on the iron, okay, if this is an iron 2, we will have an iron 3 chloride, and if this is an iron 3, we will have an iron 3 chloride. So you will still have hydrogen gas as you did for magnesium and zinc. So you will have fizzing or bubbling. But the difference here is that if you have a iron 2 compound, you will have a pale green color as you have learned in tests for ions. And then if it is Fe3 plus or FeCO3, you will get an orange brown. So if you want to see the relationship between colors and tests for ions, you can go back to your chapter on tests for ions actually, okay? And you will notice that Fe2 plus will give pale green colors, while Fe3 plus will give you orange brown colors. Alright, so iron rusting. Iron rusting is actually one of the most commonly asked questions, okay, in reactivity series for IGCSE. So iron can rust because of two reasons, okay? So the elements or the compounds that makes an iron rust is oxygen and then water. Okay, so oxygen and water are the most significant elements or reasons for an iron to rust. So when an iron rusts, it will have an appearance or a color of reddish brown, okay? This is something that you should know because they will give you a picture of a nail in exam and they will ask you, oh, what happens if you let this iron to come into contact with oxygen and water, and you will have to tell them that it forms rust and the color of rust would be reddish brown. Alright, so the chemical formula of rust, okay? So I will write down the formula here first. So iron rust is actually hydrated iron 3 oxide, okay? So since this is iron 3 oxide, let's try to write down the formula. Since this is iron 3, this will be Fe3 plus and O is 2 minus. So if we balance it, we would get Fe2O3. So since this is hydrated, right, we should have water molecules. But we don't actually know how many water molecules would be there, so we're going to write Fe2O3.NH2O. Alright. So rust is actually formed by iron with water, as you can see here. Sorry. And then the oxygen here. Alright, so you can see this more visibly here, okay? And iron 3 oxide, hydrated iron 3 oxide or rust. Alright, and then you would have your iron. And again, you don't actually need to write anything in N because it depends on the number of water molecules that you will actually have. So there are some prevention methods for rusting, okay? So you need to remember all three, okay? So the first one is the barrier method, the second one is galvanizing, and the third one is sacrificial protection. So for barrier method, barrier means that you are covering with something, right? So the iron is painted with oil or grease. For galvanizing, iron is coated with a very thin layer of zinc. So both of these methods will work by stopping oxygen and water from getting to iron, okay? So in exam, they will often ask you, how does the barrier method work or how does galvanizing work, okay? So you have to get, they usually give 2 marks for it, and then you need to answer both of these facts, okay? First of all, how would you do it, and then why would they protect? For sacrificial protection, what we do is we use metals such as zinc, magnesium, or aluminum, which are more reactive than iron, okay? So they are above iron in the reactivity series. So they can be sacrificed instead of iron. So the oxygen will corrode these sacrificial metals such as zinc, magnesium, or aluminum instead of the iron itself. Same here again, if they ask you about sacrificial protection, you get 1 mark from here and then you get the second mark from here. Very important to remember, okay? You should notice here that galvanizing is actually a combined method of barrier method and sacrificial protection, okay? So galvanizing or the galvanizing method is actually a combination of the barrier method and sacrificial protection, because by having zinc, right, you're having a sacrificial metal here because zinc is above iron in the reactivity series. So it's going to, oxygen is going to corrode zinc, okay, instead of iron itself. And then since you're coating it, right, it is actually a barrier method, okay, very similar to wall or grease. So galvanizing is a combination of barrier and then sacrificial protection. All right, so in laboratory, right, so the iron nail, if we don't want it to rust, we can actually store it under oil in boil water, or we can actually store it with drying agent. Why? Let's get to it, okay? So for for this to take place, right? Okay, let me go to another slide. All right, okay, so, all right. So explain why the iron nail in tube 1 and tube 2 will not rust, okay? This is actually because when we keep it under oil, right? This keeps both water and oxygen, okay, from getting to iron nail, okay? So that's the first one. And the wild water means that it does not have any oxygen, okay? So wild water means that there will be no oxygen. So that is why in tube 1 the iron nail will not rust. Okay, for the tube 2, okay, it will not rust because the drying agent prevents moisture in the atmosphere, okay? Prevents moisture, meaning that there will be no water, okay, to let the oxygen and water from coming into contact with iron nail, and that's why there will not be any rust in the second diagram. And you also have to mention that the main idea behind both of these methods is that we're trying to keep the nail from coming into contact with both oxygen and water. Alright, so let's do a few example problems on rusting. Alright, pause the video to actually see the question first. Alright, so name the process that we use to coat iron with zinc. It's galvanizing, okay? So the 2 samples of iron are left outside. Brown solid containing iron 3 oxide forms from sample A. Give the common name for the brown solid. Okay, since this asks you common name, right? It's not chemical name. Okay, so be careful. they want you to answer that this is rust. You can actually answer this is hydrated iron 3 oxide or anything. Okay, so the common name is rust. So give the names of two substances which react with iron to form the brown solid. Very easy. It's oxygen, O2, and water, H2O. Alright, let's do the second problem. She places an iron nail in a test tube of water and leaves it for several days. Predict the appearance. Here, very important. They are asking you the appearance, right? So meaning that what does it look like? What color does it have? So your answer should be reddish brown. Okay? You can students often lose this mark by answering that, oh, it's going to be rust. Okay, but it's actually not the correct answer. When they ask you appearance, it's usually color, okay, precipitate, and all that stuff. Name the main compound in rust. This is also another question that students tend to make mistakes. So in rust, if you answer iron, wrong. If you answer water or oxygen, you're also wrong. It's actually everything in here. So it has to be iron 3 oxide, Fe2O3. Now, you can also say that this is iron 2 oxide, okay? So all of these are wrong answers, okay? So your rust should be, the main compound in your rust should be iron 3 oxide, which has a formula of Fe2O3. Alright, so that's all for reactivity series, and I'll see you in the next video. Bye bye.